Okay, we're going to talk about when you've got two amounts and you have to decide how much of a product is made. So a lot of times when we looked at chemical reactions, we had two reactants. The lab that you guys did, you had one reactant, so you really don't have what's called a limiting reactant. A limited reactant is something that runs out. It's kind of like if you're driving in your car and your car's empty and you hear the sputtering and you're like, okay, wait a second, I should have got gas. And then you're basically alongside the road. That's called a limited reactant. You got to fill that. You got to fill the gas up. Doesn't matter how much oxygen's outside of the engine. Okay, you got plenty of that. But when you run out of gas, you run out of gas, and basically you got to go get more because it limits you the engine running. Okay, you got to have that. So we have this thing called limited reactants, and basically it's just making a decision on how much product can be made because one of them is going to run out. And you're going to have leftover amounts. Okay. Sometimes when you guys cook, you look at, try to figure out, do I have all the ingredients in which to make what I want to make? You know, you look at the ingredients and you go, okay, I need 2 sticks of butter. You look in there, oh yeah, I got enough butter. Okay, it says, you know, you need 2 cups of flour. I got plenty of that. And then you go to the sugar and it's like, there's hardly anything there and you need a couple cups of sugar. You can't make it. You got to go to the store. Or you might have like 1 cup of sugar and it calls for 2 cups of sugar. So what are you going to have to do if you really want to make...
Cut the recipe in half.
Yeah, cut it in half. Why? Because what limits it? It's the sugar that limits it because you don't have enough of it. You have enough of everything else. So that limits how much you make. That's why they call it limited reaction. So just a real simple example. Let's say I have 23 wheels that are the same size to put on this bike. And I have 18 frames. Okay? And it, you know, let's just take those two because there's a lot more to the bike than that. How many bicycles can I make?
18. Oh, no. 11.
Okay? So we know that you have to have 2 wheels for every bike, right?
Half a bike. It's called a unicycle.
Yeah. And you have 1 frame for every bike, right? So what you do, now this is something you probably in your head you've probably figured out. Some of you said the answer. But you go 23 wheels. And then you go, there's 2 wheels that are needed to make 1 bike, right? So 23 divided by 2 is what? 11 and a half. And some of you said 11.
Well, you can't do 11 and a half.
Right, you can't do a half. Now, when we're dealing with moles, we can do halves. Okay, I mean, because when I give you guys problems in that, we don't always deal with whole numbers. Okay, so you can make 11, right? And what limited you making the bicycles is the wheels, right? And so some people looked at that right away and said 18, and then they go, oh, wait a second. Bicycle needs 2 wheels, so that can't be it because make around 11, or 11's the most I can make. And so when you look at these problems, you're going to look at weights and you go, oh, that one weighs more, and this one weighs less. That one that weighs less is limiting. No. You have to go through a process of what did I do? I figured out how many bikes I could make. So this one here is 18, and now this is real simple, I understand that, but this is kind of the process you would do. You say, well, I need 1 frame for every 1 bike. And so I could make 18 if that was the limiting. But that's not the limiting because what did I go with as to figure out how many bikes I could make? I went with the least number produced, right? You always got to go with the least number produced. And so the wheels is limiting in that example. Question, I'll just do one of those examples because I think for the most part you kind of understanding how that all works. Any questions? All right. So we get to just a real simple example. And it's kind of like a mole-to-mole problem where you don't have involved grams, which is good. You don't have to mess around with grams. And so like if we have a reaction, we got Fe plus O2 make Fe2O3. Give it a real easy example. And then we know it's balanced. We need to balance these out. So there's our mole ratios. And let's say that we're given 2 moles of iron, and we're given 2 moles of oxygen, and we want to find out which one's limiting. So, which is limiting? So which one's going to produce the least amount of product?
2 moles of oxygen.
Okay, so well, let's prove that point. Let's say you say the 2 moles of oxygen is going to limit it.
Oh, that's density.
And that's fine. I mean, you got to do both. A lot of times you want to use both. Sometimes you can tell easily because you can just look at the ratios. You can tell easily which one it is. But some need that reassurance to just do a simple example of that. So down below, I'll take the 2 moles of oxygen and see how much I can make. 2 moles of oxygen. That's divided by 3 moles of oxygen. And I'm going to product, which is like the bicycles example. And I get my answer. Okay? So 3 divided by 2 is, what, 0.67? Is that?
Yeah.
Okay? So that 0.67 times 2 is 1.3. 33, well, let's say 3334. That's okay. Probably not going to be that close to where we're going to have to worry about it. Okay, so then I take my other one, which is iron, and I go 2 moles of iron, because I got to do both, because I got to see which one produces the least amount. So down here I'll put 4 moles, and up here I'll put 2 moles, labeling everything, of course. You guys do a good job of labeling, most of you. So 2 divided by 4 is 0.5, right? Times 2 is 1. So I make 1 mole of Fe2O3. So which one is limiting? Fe. Why? Well, if all 2 moles are gone, how much can be made? 1 mole of Fe2O3. Okay, so if all 2 moles of oxygen are gone, how much could be made? 1.33. So the one that makes the least amount is your iron. Any questions with that? Does that make sense? Now that's just a mole to mole, and that's pretty easy to do. Most of you don't have any issues with that. You just do both. It's just one step, and you got your answer. Now, we're going to make it just a little bit more complicated, not too difficult, because you've done all these problems. In fact, you're doing them now in the lab. You've done all these problems, and you can handle a mass to mass. Okay, you can handle that. So let's take a similar problem. Let's take reaction between acetylene, which is like acetylene torches and that. You're combining it with oxygen, which is, it needs 5 parts oxygen for every 2 parts acetylene for it to react completely, correctly. And then you make CO2 plus H2O. Okay, so help me balance that. I think that's 4 here, and that's 2 here. I think it's balanced. Yeah. Okay. So now I'm going to introduce this thing called grams. And then I'm going to say which one's limiting. I'm going to give you a certain number of grams of both. Okay? So let me think about this. Let's say that we have 20 grams of C2H2. And then we have 21 grams of O2. Okay, first thing I'd like you to do is get it into moles. So the very first thing I'd like you to do to get it into moles. So I'll give you the molar mass of C2H2. And the molar mass of that is 26.04 grams per mole. And of course oxygen, you guys know that one. So first of all, get it into moles. So on this one, we divide by 26.04, right? I get an answer. And then this one, I divide by 32, and I get an answer. Remember, it's grams to 1 mole. Some of you make little errors when you decide to make this a number that's in the balanced equation. I notice that happening. So some of you would like to put a 2 up above here for the C2H2, and you want to put a 5 in front of the O2. You can't do that. You don't do that until you do a mole ratio. So what's the answer when we take 20 divided by 26.04? What's the answer that goes in here? 0.768. You guys agree with that? Okay, and then 21 divided by 32 would go in here. What would that be? Point what? 0.656. Okay. So I think most of you probably realize which one's limiting, right? By looking at that, can you tell which one's going to run out?
Oxygen.
Okay, yeah, oxygen. Because it makes sense if we have 2 moles of C2H2 and we got 5 moles of O2, it needs almost 2.5 times this amount right here. It don't even have close. So this is a problem in my head. I thought I'd give you some numbers, and I should have did a better job and made it a little bit less obvious. But we're going to continue on, and we're going to go to let's go to CO2. So let's take both of these to CO2. Let's say the question asks how many grams of CO2 could be produced. Okay? So let's say this problem says, I should have gave this before, but let's say how many grams of CO2 will be produced. Okay? So what you have to do is recognize which one's limiting so you can figure that amount out. Now, we probably have a really good idea that oxygen is it, but you want to prove it. So what you would do for this next step, you would go to CO2. So you got grams cancel out. Now you got to go moles of C2, H2 to moles of what? CO2. So in this first one, it's going to be a 2 to 4 ratio. Okay, and we're going to get an answer out. And in this one, it's going to be a 5 to 4 ratio. Okay, and then we're going to get an answer for those two. And then we'll stop, and then we'll look to see which one produces the least amount. You don't have to go all the way to grams to find out which one's limiting. You can just go to moles of a certain product. Now this one says how many grams. But sometimes you just want to go to moles and see which one's limiting, and then if you need to take one more step further, you can. Now, you could, in the past, you could take both of these to grams and then you know your answer right away. And some of you will prefer to do that in the future. And that'll be kind of up to you at that point in time. So this first one can make 1.54 moles of CO2. That's how much it can make if the 20 grams are all used up. If the 21 grams are all used up, And we said that was our limiting probably. We could make 0.525. So we have just proven that oxygens are limiting, right? So if it asks you which one's limiting, you just have to go to moles of the product that they're asking you about. So then, if I wanted to find grams of CO2, what do I need to do on my final step?
Just convert it.
Convert which one? This one to grams or this one to grams? The bottom one to grams, right? Because it's my lowest number, and that tells me. So then what I would do is if I wanted to know grams, I would take it one more step, and I would take that 0.525 moles of CO2, and then I would go that last step. And if I go, for every 1 mole of CO2, I have 44 grams. And that, when you do those type of problems, and it asks for grams that are produced, you need to go to moles of that substance and make that decision which one's the lowest number of moles in that. So I can make 23.1 grams of CO2. And why? Because O2 runs out first, the 21 grams. So that 21 grams can make that many grams of CO2. And then we're done. It's over. The reaction's done. The reaction's done when this is out. When that's done, you have some of this left over. And in the future, we're going to decide how much is left over. That's the toughest concept that I go over in chemistry, is determining how much is remaining. For some reason, students have a real difficult time with that concept. So I'm going to give you an assignment. I'm going to have this assignment due on Thursday. Okay? And I know you got a lab to work on that's due on Friday. So you guys need to make a decision what kind of what you're going to work on here for the rest of the period. I told you I'm going to give you quite a bit of time. I'm going to give this assignment now to you. The first part of the assignment is really easy. You're just doing mole-to-mole problems, basically is all you're doing. And then the second part is a little bit more complicated. The last couple problems are a little bit more complicated. Okay. These answers, you can look up the odd answers. You'll have to turn this assignment in. This is an assignment that needs to be not done in your notes. So these 1921 A and B, you guys can check your answers as you're doing them. Then you get to 22, and the evens you can't. So that lets me figure out, do you really know what you're doing? 23A, you can check your answer. And then the last two, 24 and 26, you can't. So half of these, you guys can check your answers as you go. Just to see if you're setting up if you're getting these answers wrong on 19 and 21, those are just mole-to-mole problems, then those are the simplest ones. They're just mole-to-mole ratios.
So is it 19, A and B, 20, A and B?
19, you're going to do the whole thing. 19 is kind of an example like the bicycle. It's a real-life example.
Okay.
That's pretty easy. You know, it'll take you probably a minute to do. Okay? All right. Now, if you have some more to heat up, you want to do another heating, you got enough time to do that. If you want to get on a Chromebook and start sharing a page between the three of you so you can start putting your calculations in. And I'm just letting you have freedom. And then tomorrow I'll probably give you a lot of freedom too. Does that make sense? Tomorrow I'll probably give you a lot of freedom as well. Okay. You may go ahead and do what you need to do to get rolling. I'll have to open that. Okay.